Good afternoon and welcome to the first webinar of our 2018 Webinar Wednesday series. We are excited to have nearly 400 registered attendees for today's webinar, which is eligible for 1 credit from the ACI. MD Publishing is focused on giving back to the HTM community, so let's kick off our 5th year of Webinar Wednesday by giving a Webinar Wednesday surprise pack to the attendee that can tell me what percentage of roses purchased on Valentine's Day are red. Answer now using the questions feature on your dashboard. While you're answering, I want to remind everyone that MD Publishing hosts 4 conferences a year, 2 MD Expos, ICE, Imaging Conference and Expo, and OR Today Live. Now, our first Expo, ICE, takes place this Friday, the 16th through the 18th in Las Vegas. The registration is still open, and to receive complimentary admission by using the VIP pass, compliments of Summit Imaging, found in your Webinar Wednesday workbook. For more information, visit attendeeice.com. Okay, and the winner of our Webinar Wednesday surprise pack is James Swandle. Congratulations, and the correct answer is 75%. Webinar Wednesday would like to thank our sponsor, Summit Imaging. Summit Imaging is an ultrasound parts and transducer repair company that can quickly address specific technical needs based on a foundation of outstanding rapid customer service. Their philosophy is simple: make their customers heroes. Visit mysummitimaging.com for more information. Now, our presenters today are Larry Nguyen, CEO and CTO at Summit Imaging, and Carl Grozelle, Manager of Global Education and Training at Summit Imaging. Larry and Carl, you may begin whenever you're ready.
Hey everyone, Larry Nguyen with Summit Imaging and
Kyle with Summit Imaging. I'm the Manager of Training and Education.
And today we wanted to focus our discussions on some high failure equipment in ultrasound, and that's specifically TEE probes. And we have a lot of examples to show to you today, and this is something that Kyle helps constantly with during training, either in-house here or flying out and helping our customers identify the points of failure, because we're seeing a very high pattern of preventable damage, and we really want to share the information on how you can best protect your equipment, but it also increases the repairability of the equipment too, because oftentimes the damage is so severe and there's so much corrosion, there's just literally nothing to work with anymore. I mean, you think about the environment in which these are used. First and foremost, these go down the esophagus and scan the heart where there's no bone material in the way, so you get a phenomenal image of the heart during your cardiac exams. But number 2, it's an acidic environment in there, so there's sitting in stomach acid inside the esophagus, some sort of acid, right?
Yeah.
And then the moment it's removed, it goes into sterilization, which oftentimes it sits in acid of some sort, and so these really live a pretty harsh life.
Yeah, and not only that, but we're finding as budgets kind of get constrained, and more and more surgeries are happening throughout the day. These probes are actually going through that cycle 3 or 4 times a day.
Absolutely.
And then maybe hitting the end of the day and sitting in a tote overnight before they're worked on the next day. Yeah. And I always tell people during our visits, during any sort of training class, it's that little piece of advice: you're fighting time versus fluid, whether it's acidic, water. And then how long is it there? Is it just a quick drop, or is it sitting in it for a week while you're down?
So this topic was really important to our customers. They actually asked us to make this video because there's 2 major factors here. The acid is really harsh on the materials that's coming in contact with it during the scan and sterilization process, which kills the equipment. And number 2, it's the fluid. And these are all electronic devices, and electronics and fluids typically don't go together. So once those start mixing, you start seeing some really catastrophic failures. And Kyle's going to walk us through kind of tip to tail on what's in these and what the common failures are, to help educate you, our healthcare facility customers, on how to keep the equipment up, prevent damage, and ultimately lowering your total cost of ownership. All right. So Kyle?
Yeah. So like I said, this is a big cost of ownership across the life of these transducers. Now, one of the biggest things that comes up is they're waterproof, right? In the perfect world, yes, but we have situations in the OR where maybe they get bites on them. Even if they're using bite guards, maybe it's not a proper fit. And just starting at the tip, you already have a array, wires, and steering mechanisms that can now be affected by that stomach acid, your cleaning solution, or even just water.
Okay.
All right. So starting at the tip, typically, and we're going to go a little general on these transducers since we're going to talk about GE, Philips, and some of the others. But you'll have an array. It'll have a head, a distal steering area or control mechanism that is softer rubber, and then your actual tube. Now, this is your failure area right here. This is where a lot of your damage is going to occur. This is also where all your sensitive components are, and really where you want to be teaching places like central infection or decontamination, or even your nurses in the OR where to look for problems. Is the seal in place? Is there chips on it? Simple things like this can actually keep going on and on for a couple weeks.
Yeah, and I think those are really important because if there's a small chip, even using a magnifying glass, you actually bring a magnifying glass to your classes. What may seem nominal, it doesn't take much more than a pinhole for fluid that's during a sterilization process to seep through. And the other opportunities when the probe's inside the esophagus and there is a small pinhole, because the muscles in our body will actually start pushing in the stomach acid into the electronics on the inside. Two issues. It's dangerous for the patient, but it's also dangerous for the equipment, right? Let's talk about the patient first. It doesn't take much to transfer current that should be insulated on the inside of the TE probe for it to escape into a micro pinhole, and if the human is then exposed via a pinhole anywhere in the transducer, the patient becomes the ground. So the patient can get a shock. Especially dangerous when these are actually resting very close to the heart in the esophagus to get that proper scan. Number two, dangerous for the equipment too, because the acid and the fluids and all that stuff that's being used in these caustic environments that these probes go in, it goes into the probe and it actually shorts them out. And if it's not cared for quickly, probe and patient's at risk, but the probe gets the brunt of it because the acid sits on the inside. So can you talk to us about, when you're talking about these like the pinholes that we're looking for in here, when it gets in, like what are the problems?
Well, I have one that's open, so we'll switch out here in a second. But one thing you also miss with the patient is cross-contamination. The big oh no when it comes to an OR.
That's especially bad.
So 1 second while I step out of frame and come back with this lovely guy. Now, this one has had a bit of a rough life, but it does serve as a great example, and we'll actually get some nice close-up shots here in a moment. But we have an array as well as the lines leading to it. Now, these lines are coax lines about the size of your hair. One drop of Cydex solution, OBA, stomach acid, or even some water, and then say it sits for the weekend, this entire head will just be full of rust. All of that would start flaking off. And it's because of a pinhole or maybe a small crack in the head. And when we say fluid intrusion, sometimes it's not massive. It's actually just a drop, but it had the time to sit there and do the damage too.
Yeah, I think during our training for our internal probe technicians here, we actually demonstrate, we take a pipette and we take just a little bit of rubbing alcohol and we just put one drop on that small PCB there and the entire bank of lines that are soldered, which are about 26 to 28 in one small little area, the entire thing is now shorted. All the signal lines are now shorted to each other from one drop.
Very quickly.
From a pipette.
And it just acts like a sponge. And and
it's conductive.
Well, and even one of the best ways to store these is hanging. So even if you get some fluid in your handle, guess where it's going, right?
Oh yeah. So what happens is if the fluid's in the handle, maybe from like washing it, we'll talk about that in a minute, and it's hanging like this,
just travels.
The fluid just simply drops down and actually collects at the most sensitive piece of the equipment. So is it a good tip that if you are suspecting that there's fluid intrusion that you actually go the other way?
Yeah, you want to go the other way when you're shipping it. One of my pieces of advice is get yourself some like silica packets or something, and just do your best to get
and all
liquid
electronics,
away.
right? Like you always have those silica to draw out the moisture as much as you can.
And if you suspect fluid intrusion, if you're get this thing opened as quickly as possible. At Summit Imaging, we eval them for free, and even just as simple as doing an eval, getting it open, getting it dried out, even if there's nothing wrong, and we're able to just reseal everything, we've prevented so much damage than letting it operate with that fluid intrusion for a week before it critically failed.
Yeah, I think that's what our customers love the most, is that the expeditious repairs of nothing's functionally wrong with it except for possible fluid intrusion.
Yeah.
But the fact that we're able to open it up, get it dehydrated, clean it out as quickly as possible, it prevents the fluid from traveling to the sensitive part and possibly deeming it unrepairable because the damage is beyond repair.
Exactly. And we'll talk about that more as we maybe talk about the life cycle of a probe.
Got it.
But let's continue up. You do have your tube, your distal tube. And in a perfect world, I think we actually have, almost a good one and almost a bad one here. You're going to have your depth markers and a nice, gleaming finish, like a new car. And you can see here, this one's pretty chalky. We'll actually get close up on it in a moment, but you won't be seeing a lot of puncture marks on a transducer in this area, unless maybe, you had like a lion on the table or something.
Yeah, the insertion tube piece here is pretty darn tough.
It's reinforced, it's thick, but we've seen them get run over by carts before, squished in doors.
So when you're talking about running over by carts, I think it's accidentally hanging off the side, and somebody pulls the ultrasound machine and the wheel crushes it in the middle.
A bed, an ultrasound machine, maybe a cart they're moving it around on. Yeah. It's all accidental.
We've actually seen recently where we don't know how it got damaged, but it looked pretty bad. And it was interesting how there was some 90-degree creases in there. And so we actually looked at the insertion tube after we removed it and put it in, eyeballed it against the jamb of a door. There's a really great chance that was actually somebody was holding it over their shoulder or holding it out, and then the door slammed and it just crushed the entire insertion tube.
Well, and some of the cleaning systems use a door as well. So it could get squished by just the right angle coming down. It's not coiled up in the bin properly. A lot of the systems now are going vertical, like the TD100. So the nice thing is you can't really pinch anything because it just goes in.
Got it.
But there's other scenarios. One of the other issues that can happen with these tubes is, again, the discoloration. And that can come from improper mixture of your cleaning. And what you're doing at that point is if you get a foggy distal tube, imagine how the softer rubber and the beads up top are taking that. This bending rubber might be wearing out very quickly, and the only sign you have of it is this fog right here. Maybe that's a transducer that's been up in the rack for a while. You don't know what's wrong with it, or it just seems to throw an error every time. And well, you could get that repaired very quickly instead of just dealing with the problem, right?
Yep, absolutely.
You do have a strain relief on there as well, but coming up to the handle, and one of the biggest things I always have to point out to people is these handles do have O-rings in them, but they're not waterproof. They're water resistant. You got a couple seconds to figure it out, but you'll have your steering mechanisms, your controls for the tip, usually a lock for your steering mechanism, but inside of that handle is all the lines going down south to the tip. And this is where I see a lot of problems happen on our discovery reports that we do for our customers, is fluid has gotten into this handle and it's shorted out these connections right here. Okay?
And it's also key to say here that when there's fluid intrusion here, because when you look at the entire transducer being giant circuits that are going to the array and coming back to the system, that fluid intrusion here is nearly the same symptoms if the fluid intrusion occurs here at the tip.
Oh, exactly.
Because you are shorting and frying the circuit, and the machine doesn't really care or interpret where the short or the open is, where it's not supposed to be. It just sees that this channel has a failure, and it's going to represent a bad image at that point.
Well, and you can spend a lot of time chasing a problem too. Say you have a spike. A spike can be caused by two lines chafing on each other. Now that can be in the tip, that can be in the handle, that can even be back in the can that we're going to talk about in a moment too. There is, yards of line for each channel inside these transducers, and you have a few connectors, a few kind of halfway points where you can isolate it and see if the signal's going through clean there. But a lot of the issues happen, and they happen in the handle, just because that's where, when you're sterilizing these, it's the best place to hold on to. And I've seen so many times they go downstairs, and the techs are working hard. They have more than just these transducers to get through. They have everything else that just came from the OR, and they grab this with their wet glove. All right, and it's water. It's just from the sink that's running. And it just gets into the handle, right? And they're getting their wet glove all on here, and there's an O-ring right here, but a few drops will get in and just sit. And this takes a lot longer. This means, it's gone through a few processes where it's gotten wet, but maybe your steering mechanism starts to rust. Your lines start to get eaten at. And the probe fails. And you think it's the tip, but it's actually up here. Or we talked about hanging it to store it. That water gets in there.
And then it hangs and goes down. Absolutely.
All right. So as we start looking at the rest of the transducer, things start to get a little standard. You still have cords and connectors on your C52, C51s, everything else you see across. But it's still exposed to a way harsher environment. You can have the problem with getting rolled over by carts. It's traveling down hallways. It's in totes. So the strain relieves on these T-probes are something that you want to look after and give some actual care to. Inspect regularly. We get a lot of pinch cables just from being shut in a machine door, a lot of the sterilizers, because you want to keep this can out of the sterilizer. Means a pinch will start to form kind of in the same spot on the cable every time. And then we see a lot of damage just from the transportation. This connector hitting the handle while it's in a tote, or they usually use like a tote or a sterile box to move these around.
But the sterile box has everything combined together, and kind of as you're walking and you sway,
just sitting on top of a
you're really
towel.
exposing the most sensitive part of the probe to get hit and impacted with the connector or the handle here, and causing some unnecessary damage. So I think one thing that Kyle is talking about is really caring for and protecting the sensitive part of the transducer, which in this case is the distal tip and the array up here, and keeping it away from impacting the really rigid and heavy duty, relatively speaking, to this, because a light piece like this with the materials it's made of, taking an impact to at this point solid metal, that's going to lose every single time, and that's the most valuable part of this transducer.
Well, and one of the concerning things for me, like even just taking this transducer and having a look at it, if it's shipping damage, that's a whole other story. But this is chipped, this is cast, and it's chipped off from an impact.
It looks like somebody dropped that one.
A drop to the floor. But what if that was inside of a tote while it was going down the hallway? One of the other situations too that we see, just like the handle, is this getting grabbed with a wet hand, and this is the solid connector.
And then you see the corrosion and the moisture buildup and the oxidation that occurs inside here.
With something that you think should be almost a yard away from the liquid environment that the probe is being sterilized in, right? You got a lot of cord to work with here.
I think we've also seen that if you look inside the connector here, there is no O-rings.
Nothing.
And so when there's actually fluid intrusion into the connector, when somebody grabs it with a wet glove during sterilization or whatever have you, there may be some
it's just swimming
opportunity to maybe clean it out with some paper towels or some dry rags to where they can cover the tracks here. But the fluid is actually on the inside where all the electronics of the connector lie, and therefore can cause shorting. And we've seen shorts so severe that it actually blows traces and whatnot inside inside the PCBs of the connector.
Let alone this is the ground to the machine. So we talked earlier about exposure with the patient to losing the ground, and then the patient becomes the ground. This is where the end of that connection is going to be. So if it's not connected to the system properly, say the locking pin is loose because it's been damaged, or we're missing a nice big chunk out of our solid connection.
Yeah, let's chat about that for 1 second, because we've had some interesting experiences on probes coming in where there was just a lack of understanding on how these are built, and then some really odd repairs occurring, and it puts the patient at risk. So to be very clear, there's grounding pins. The locking pin is part of the ground circuit. The screws that hold in the connector into the can itself is a part of the grounding circuit. And we've actually seen these connectors been counterfeit or improperly remanufactured, whatever term you want to use, made out of plastic.
Yeah, plastic, 3D printed, and then they were spray painted to look metallic.
And they were spray. But what happens is, if this actual physical can that we knock on is metal, it is not metal anymore, then it's no longer conductive. And if it's not conductive, your patient now becomes a floating ground. And so that's one of the things that we inspect for every single time, to make sure that the correct parts and the OEM correct parts for these critical pieces are there. There's so many people out there that may misinterpret this as just a cosmetic can that just holds it together and looks pretty. No, if you actually take a DMM and you analyze this, it is actually a part of the ground circuit, and it is critical to the ground circuit.
Yeah, and well, that and plastic, like, it's not even close, right?
Not even close. No effort to be even partially close at that point.
And then one of the things I see happening a lot is that these little rubber covers disappear, but they actually serve a purpose. Just like when we were talking about it floating around in a bin, that is going to actually soften up some of those impacts to the tip.
Yeah.
And just having this available and not ripping it off your transducer whenever you get it is useful.
Yeah, and to reinforce the point, these little covers are from the OEM, and it actually says no fluid, so don't put fluid in here. That can cause some pretty serious issues for the patient and the transducer here.
Well, it at least gives you one more barrier protection as well.
Absolutely. Absolutely.
So moving on to what we're going to talk about next is taking one of these through the life cycle in a hospital. You have usually a kind of a fairly universal life cycle. Some hospitals keep their inventory right next to the OR. It's downstairs, vertical cabinets, totes, but they all kind of follow the same method. OR, transportation, sterilization or disinfection at this point, because they're never truly sterile as a T-probe. Then repackaging, waiting for the next OR, and then back into the next. So there's opportunity for improvement across that whole cycle in a hospital. Even in the perfect scenario. There's things like wrapping the handle in a towel, or throwing away the sponge. But we'll talk maybe more about some of the horror stories we've seen, and the do's and don'ts, but also just like best practice.
So I think the purpose of this is to demonstrate and articulate the things that we are literally working with our customers to prevent these what we believe are unnecessary damage. But I think what we can't forget here is that we're all humans, and we're going to make mistakes, and it's all accidental, and nobody wants the equipment to go bad, to go down, and then you have downtime and the patients can't be cared for. But this really speaks to the quality of the training that needs to occur. And we see that this training is such a small investment from the healthcare facilities for such a massive gain. And the massive gain is protecting the probes, having them stay in service longer, less downtime, which means lowering your total cost of ownership.
Exactly.
And so, I think that training piece on what we're seeing and, what we help customers with in healthcare facilities, that, we go in with, a very clear optic of just, we literally follow the probes around, and we'll go into the OR and we'll see it, and we'll just build these reports to identify the points of improvement. So what always happens during those is that everybody involved in the process knows we're coming in.
Yep.
And so at that point, we may catch a few things, but everybody is definitely on high alert that, this is under scrutiny. This is a big opportunity for savings by protecting the equipment. They're going to protect it in front of Kyle every single time.
Yep.
But the moment Kyle leaves and somebody else starts performing the work, we find that it's where that occurs, where you might have somebody inexperienced beginning to work on this. So we're seeing a direct correlation with training, but on top of it, the turnover of the disinfectant and sterilization departments of healthcare facilities. That's a direct correlation to the frequency of failure and the frequency of catching these failures early enough to where you can repair it.
Yeah, I always kind of get that comment actually. It's like, this wasn't about a year ago. Well, what happened 11 months ago? And that's when maybe a tech left or, this main person changed over. But on top of that, it's really critical when we do these visits and, do the trainings to look at the history too. Yeah. Walk into the building knowing what's happened over the last 6 or 7 months and being able to think about that as we observe and realize, oh yeah, they're using a bite guard today, but all the things we've seen are from bites or fluid intrusion from grabbing it with wet hands. So
and we always learn out there too. We're out there actively building this knowledge base and sharing it with all of our healthcare facility customers. But we're always amazed by some of the damage that can occur. And like, oh, that could happen. And an example is, it gets caught in the door. That was a bit of a surprise, but you know what? It happens. It's an accident, and unfortunately, it did happen. But you can prevent it in the future by just knowing how to transport the probe in a bin rather than transporting it by just kind of holding it like this and trying to race through a door type of scenario.
We've learned positive things too. New methods of storage. I've been in one place where they actually devised a little hook system right above the sink, so they didn't have to hold it and worry about it slipping in. So being able to see these things and help others in the industry apply them has been pretty fun. Okay. So starting with the cycle, I always kind of start with storage. See where they're kept. More importantly, I'd like to know the life cycle of the storage. Right there next to the probes, there should be the last test report. Hopefully a whole book of when was the last time this was leakage test, who's the last time that did it, pass, fail. If it failed, it probably shouldn't be there, or it just returned to stock from being repaired. And then, what's the life of the transducer look like? Now this could be downstairs too with the biomed shop. It could be with the OR manager, but this information should be easy to find. And we should know what's happening with this transducer next and where it's been. Most importantly, if it's failed leakage, where's it going to now? Is it going to go to biomed for another checkup, make sure that leakage test failure was accurate, or is it going to go straight out to a vendor like Summit Imaging to get evaluated as fast as possible? In storage, the best situations I've seen is it's stored vertically in a cabinet right next to the OR. Now, there's actually products out there that is a HEPA filtered cabinet, which is pretty much the best case scenario. It keeps things dry. It keeps it sanitary at that point as well, or disinfected. And then it's right next to the OR for easy use. So you don't have a transportation, in a bin carrying it in that rush to get set up for the next OR.
Exactly right.
They can grab it when they need it. Even better is if they need, to switch something out, they're not having to call downstairs to find another one or rush one through sterilization. They can look in the cabinet. There's a glass window on it. They know how many they have kind of ready to go.
Less time in transport, less risk of damage, unnecessary damage.
Exactly. And not being stored in a tote means someone's not just grabbing it and throwing it into the OR. So less opportunity for this candy to fly around.
So when we're talking about tote, it could actually be like a big Tupperware box that it's in, or we've seen the cloth bags, like a pillowcase.
I've seen those.
Those are just terrible. Don't use those because the pillowcase in and of itself, all the heavy things go to the bottom of the bag and they start banging around together, and the three heavy parts is the connector, the handle, and it's going to be the tip.
There's quite a few options now. You got some medical grade totes. I've seen Walmart totes, with the lid and it's cracking and it's just worn out. And there's even some new products coming to the market right now where it's a big metal holder that has an actual tray to hold the lines and everything. I hear those are quite the investment, but the nice thing is you can also run them through your autoclave.
Yeah,
You
nice.
can clean them quickly and easily. After it's in storage, it's obviously going to go to OR. Now, if you're using your bite guards, you have a good skilled technician at the head of the patient, nothing's really going to go wrong there besides a failure that was caused further down the line, back in sterilization, disinfection. Yep. But the bite guard is something where it's a bit of a hot topic. Everyone says they use them. Everyone does use them, but it might not be the right fit. It might not stay inserted the whole time. There's a whole just echelon of things that can go wrong.
Yep. But we've actually found some, you were actually at a site where, they were using a bite guard, and we'd actually discovered why the faces of all the probes started to get nicked constantly to a point to where it would compromise the leakage test results, because it would have eventually ended a crack or a puncture. Yeah. Could you tell us about what you found during that study?
Well, I did find some situations where before and after the study, the transducer was just being stored with all the other surgical equipment.
Yep.
So it wasn't the bite
surgical
guards.
Equipment, just to be clear, they're pretty sharp.
Sharp, heavy, purpose-built titanium, steel. Yep. And I get it. Like, you also are trying to clear the table as quickly as possible. You're doing inventory as you're closing the patient up. They're trying to account for everything, and this guy usually stays in till about the last moment because they use it for temperature as well. Yep. They're running a study the whole time.
Yep.
But then it just gets tossed on the table and some instruments hit it. Yep. That's it.
And this is rubber. So any lacerations of that rubber, the internal electronics now are not exposed to anything on the outside, being patient, sterilization fluid. Those are both very bad issues, because then you've got cross-contamination risk. And I think the other one was you discovered that on these T probes in particular, you can actually lock them, and this is to apply pressure inside the esophagus to get the best image possible of the heart. But when these are pulled out of the esophagus, when you lock this probe to get the best image of the heart, when this is pulled out, the bite guard may be up front, but the molars in the back, because it's locked, this will be hitting the back of the molars and just dragging across all those teeth. And with enough impact over time, can start compromising the leakage properties of this. It could crack the plastic. It could compromise the RTV that's sealing the lens and around the plastic. And all these kinds of things. But those are the things that we're learning with our customers, that as simple as, okay, let's make sure that it's standard procedure to unlock the locking knob, so it now releases tension, and then when you pull it out, it allows for this to come out safely. And quite frankly, even though the patient's under anesthesia, it can't be comfortable having this thing dragging 90 degrees up the entire esophagus.
Yeah, just like the fish we caught when we were kids. You got to be kind of nice to it, otherwise it's never going to come back, right? Yeah. On top of that, things that happen in the OR, like, okay, we need to pull it, we need to go fast, and they're just placing it over the control panel of the machine and just letting that array tap the side. Yeah. Doesn't seem like much when everything else in that room is titanium, but when you have this little crystal right here and it just hits the side of a cart, it cracks, and it's gone. So there's lots of room for improvement even in the OR.
Yes. Now,
after that, this first step usually still happens in the OR, but you do like a high-level decontamination, usually a wipe down, and a lot of places use a pre-soak sponge. Okay? They just bring everything out right away in the OR. I can't tell you how many times I've seen that pre-soak sponge go down the probe and then right into the tote with the probe that's going to go downstairs.
So as we were saying, in the tote, then now the sponge is with the connector open like this.
Handle.
And with the handle, got it?
And that sponge is still, I mean, if you ever grab those things, you can wring them out for a good minute and get, a puddle going. And in the best case scenario, your transportation has maybe a towel or something in it so it can sop some of that stuff up. But usually, you just have this soaking wet sponge floating around all these components as it goes downstairs. Now, it goes downstairs Friday at 4:30, and it sits till Saturday morning or worst case Monday, and that sponge just had all that time to let its rather, low acidic cleaning solution get in here, but it's still soapy. It's gooey. We've had lots of probes opened up where
the point is it's fluid and it's still getting in.
It's getting in there, and it's nasty stuff too. So it's actually a lot trickier to clean that up because not only are you looking at corrosion, but you're looking at usually a buildup of some kind. Whereas in the OR, all I had to do was wipe it with a sponge and into the garbage, into the medical waste, and everything would have been solved. That transportation downstairs, kind of this blankets both upstairs and downstairs. I kind of say up and down. Sometimes it's just across the hall for sterilization, but if they have it in a tote, in a cloth bag, in a super heavy duty reinforced cage, still, if it's got fluid in it while it's being transported, you're already having that travel happen that we talked about before too. It's moving around. Once it's to disinfection, there's usually 3 stages. There's a high-level rinse-off that just happens in a sink, where they're going to remove any sort of matter that built up, and that's usually the first opportunity for this handle to just get pulled into the sink with the rest of the transducer. Okay? They're trying to get the tip. They're down there. They're scrubbing away, and this is sitting up on the sink and just falls in. They grab it with their hand. They put it back.
And their hand is wet.
Their hand's
soapy.
Wet.
It's catching it.
It's now full of water. Like I said, one of the nice practices I saw before was a hook, where they were able to actually use this ring and secure it from falling in, or place it on the counter, wrap a towel around it. That little bit of friction is going to stop it from going anywhere. Also, you're not going to grab it with your wet hand. You now have a towel, for that transportation. Now, this step is also the best time to look for those bite marks, and this is where our infection control team could use a little bit of education. They're just trying to clean this off, but if they actually stopped for a moment, did a quick inspection, look for a nice tooth grind from the molar or a pinhole, and more importantly, actually articulate it while they're doing that, and move everything around to possibly expose a hole that might be sealed up.
Gotta get
we can catch it.
You can stretch it and expose some of those pinholes to where, with the naked eye or a magnifying glass, may be difficult. So if you kind of work it a little bit and you stretch it out, you might expose that. And if you see a pinhole, there's no use for a leakage test. It's going to fail.
Send it in before you expose it.
Send it in before any more damage occurs. There's probably already fluid inside, so the faster you can get it into a service organization to dismantle it and get all the fluid out, then the higher the chance that we're going to be able to save the probe.
Well, not only that, it'll be more like a maintenance repair instead of a full extensive repair.
Instead of full extensive rebuild everything, it becomes a routine, quick disassemble, clean it out, get the electronics back to where it needs to be, and then reassembly, and it goes back, which is a much simpler process than fully disassembling the entire probe, going through a full repair refurbishment process. Obviously different prices as well. So that little tip there, where if the infection control or sterilization department, whatever you're using, can catch those things early, then it benefits you in a couple of different ways. It prevents the risk of cross-contamination, prevents risk of injury to patient because of leakage issues, prevents further damage of the equipment, and gives you a much higher yield of repair maintenance type of activities rather than a full rebuild of the entire probe. These are expensive, so it's nice to do a little maintenance repair rather than a full shebang repair on this. But there's so many advantages on some really simple tricks and tips that we're kind of revealing here for our customers.
Yeah, well, like I said, with maintenance, a lot of people are kind of, these transducers should last forever. You're dipping them in acid. Every day.
They live harsh lives.
So yes, the internal should last a very long time. Your bending rubber is going to deteriorate over some time. just like our foggy line on our other probe, you're going to see this stuff build up. It's never going to be perfect, but if you can just have those maintenance occurrences instead of having a critical failure or a full rebuild, or worse, it's just not repairable, you can avoid a lot of that cost and extend the life of this transducer, which is the idea, the cost of ownership, right?
Absolutely.
The second stage in that cleaning process will then be to go into decontamination or high-level disinfection, whether it would be a Cydex bath, where there are totes that have ways to hold the handle, or a vertical cleaning cabinet like the TD100, where it uses cartridges to hold its solution. This stuff's pretty straightforward, and it runs the cycle automatically. You do want to stick to the cycle as a key. GE and Philips released the documents on their proper cleaning procedures. They're available online. I'll find a way to tag everyone in it. Share it as much as possible. But if you leave it in that Cydex bath for an extra half an hour, what's going to happen? It's just going to continue to eat away. Or if you have a pinhole, you're just letting more drips go in. And then if you dunk things like the connector or the handle in those cleaning solutions, they're not built to handle it. So even worse, if it slides in while you're gone having lunch, right? The nice systems like the TD100, it holds it, and the cycle runs automatically, and then it rinses it, and it just sits there and waits for you at least. My favorite too is it even prints out a little receipt.
That's the record keeping is extraordinarily important here.
So you can take that, store it in your records. There should be a record of that every time you sterilize something or clean it, and then a leakage test should occur. That's our third step. It's not very risky. Usually it's in water or maybe a saline bath. But if we have a failure at this point, we just wash it in Cydex or OBA for half an hour. So we should pull it and get it gone as soon as possible, get it opened up, get it dried out. But you may have situations where it's a false failure because maybe the probe wasn't set properly into the cradle, or it's your connector causing the failure and there's actually nothing wrong with the head. There's lots of good testers out there. I personally, like the ones that give you a little more than pass-fail. They give you an actual readout. Even better, there's some that connect to a label maker. So you can take that label and slap it in that logbook when you're done. And then this is when a final inspection would want you to have it occur, right? You've done your leakage test, you've passed, but there are some things like, again, the fogginess on the line, maybe some scratches on the head, your lens is just tarnished, and you want to give this transducer a good one-over. At this point, you want to maintain the disinfected state, so obviously gloves, everything like that. But check out the beads as well. Are they starting to lose their color? Are they scratched up? A lot of our canines, things like that, like to chomp on them as they come out. Even if the bite guard's there, something may have happened. There's scrapes.
So even if the process goes through perfectly, we really recommend that final visual and really just manipulating the bending section of the T probe here, because by virtue of it being a rubber, that if it's going into the leakage tester straight, if there is like a pinhole on this side, it may actually close itself when it's straight, but the moment that you articulate it forward, it may stretch that hole out, and then fluid starts getting in, cross-contamination, leakage failure, all that. But you have to kind of induce the issue prior to actually using it on the patient again. So we really recommend that visual test again to do that, or even manipulating it during the leakage test is a really great idea to expose those issues.
Doing some bends and then rerunning your test while you lock it in a position.
We see so many times where you just dip it in there, it pass, and pull it out. Well, there really is a laceration or a pinhole there, but it's just tight together and no fluid's getting in at them as in the moment. But the second you move it, it's exposed.
And you got to remember that's rubber, so it's got some elasticity to it. The situation is going to change every time you use it.
Absolutely. So let's take a peek at some of the things that end users would see as far as image quality. So all of this is about patient safety, but at the same time, it's also patient care, because these failures in the equipment doesn't always result in the equipment not working. More often than not, it is just bad image quality. So
Yeah, bad image quality is usually the first thing reported.
Exactly.
And then it comes in and you find corrosion, lines crossing over,
so
things just missing.
Yeah, so typically it starts with poor image quality, and then it degrades more into ultimate failure. Once it gets into ultimate failure and the system coughs up errors, I don't like you anymore, I don't know who you are, or whatever it is with this transducer, at that point, it's a Hail Mary pass to try and fix something like that. Whereas if you're seeing some light CW noise, that's a great time to get in right now. The probe is very repairable at that stage. So let me pull up some pictures for us to chat about that.
Let's have a look.
So tell us about this. Probably the most common symptom and failure that we see as a precursor to the rest of the probe, kind of absorbing all that liquid and damaging itself even more.
Well, and this wouldn't be reported, quickly. CW noise is what we're kind of experiencing here, and it's actually happening probably only in a certain area of the array. If you move to the left or right, it might actually clear up. But what that's telling me is you have fluid sitting on some lines, or worse, they've actually started corroding and they're touching, and you're getting some chatter, you're getting some static, just as it scans into the air. Now, this becomes harder to detect when it's on a patient. But you're suddenly just going to have your R go, well, we can't really get what we want to see out of this probe, and it won't be their favorite one anymore. It'll sit on the shelf. It'll get worse. It'll get worse until the machine doesn't work.
On top of the spiking you see, but it's also if you just for basic image quality, above this axis here and below means to and from. The blood flow from the face of the transducer, and you can't have fluid going to and from at the same rate at the exact same time. It's just physically impossible. So you really don't get the proper waveforms of blood flow that they're looking for.
It's a chatter instead of a waveform. You're just getting a spike.
So this is what we've been talking about, and this is actually, it's a circle because we're underneath a microscope here, but Kyle, tell us about what's going on.
That tip right there, this little yellow sticker, is probably what the size of the tip of those tweezers I just happen to have on the table. And that bite mark might be like about the size of a needle hole. It's going to be very hard to detect to the naked eye, but that bite mark can let in 2 or 3 drops. And 2 or 3 drops of Cydex or OPA can start doing a lot of damage to the transducer.
And then especially hanging upside down, it enters here, gets to the crystal,
goes up to the head.
Start seeing a lot of failures there.
Now this is the one that you can see. There's probably going to be one on the other side, because your mouth works on 2 directions. And you may have multiple across the hole. In fact, you can see
there's another one right here. Even smaller.
But if we had caught this during the leakage test, during our initial disinfection of this probe, we would be able to get repaired very quickly, very easily, and there wouldn't be fluid really anywhere.
So I think this is an example of a probe that's pretty far gone, and you're seeing a ton of noise across the entire image, which means that there's been significant degradation of these circuits, likely at the crystal. Could be anywhere in the transducer, but in our experience, we've seen a lot of this, and this is a point to where there's so much damage at so many of the interconnects from the lines that are inside the probe that go to the crystal, that this is going to be a tough one to recover. This is at this point, this probe is likely unrepairable. There are instances where you can recover from this, but the odds aren't in our favor when you see this on your screen.
Well, looking at this transducer too, like the lens appears to be not showing up properly in the image as well. It's gone.
You should see at least a raw band up here that's it's gone now.
And you should have the little tulip. It's not even seeing basically its own lens in the image.
Exactly.
This is a pretty extreme example of maybe a wet hand grabbing the handle. More likely, it probably slipped into the sink.
So to give some context, this photo here is when you open up the T-probe handle. We're looking at the inside now. So this is a fluid that got beyond the metal casing and the O-rings, and now it's appearing here on the internals that actually move and articulate the lines to get these Omni probes to move where they need to.
Well, and on the other side of the connector, you can actually see a bit of the knob right here. On the other side, is our line splices, you know, our bridges to go down to the head. And if that much moisture is back there, you're in a lot of trouble. But you can already see the buildup too. You know,
the corrosion
it's
that's
been
occurring here.
And this was probably just water. Yeah. Maybe had some soap in it, maybe had some disinfectant, but
what's amazing about this photo that you don't see is that there is the bundle of the electrical lines that go from the connector that goes to the ultrasound machine all the way to the crystal. That's underneath. And so not only is the mechanicals of the articulation lines exposed to this fluid, so are the electrical lines. Luckily, they're wrapped up pretty good, so there's typically not too much damage there. But, you know, we work on electronics, we repair medical electronics, and it's always a safe bet that electronics and fluids never go together. And so, you know, this is just another risk factor, you know, for all the things that we've talked about before, where, it's obvious that it's on the mechanicals, but, you know, just as important is that there are electrical lines behind this that are going to be exposed to the fluid as well.
All right. Yeah.
So the damage here is it's a pediatric TEE probe, and you can see that there was a lot of fluid intrusion to where the entire internals of this transducer on the tip. So the crystal is actually face down here, and that sits on top of this disc that rotates the crystal for the you know, the physician to get the image that they need at the right angle. But this is not supposed to be brownish orange. This is actually rust. The whole, you know, so everything is rusted out. So, you know, for us, it becomes an extraordinarily gargantuan task to try and get all that out there. And all this work is done underneath a microscope. There's no way you can do this work without a microscope and a very skilled technician. And so you start to question, you know, are the lines, the articulation lines, are those fused together or not inside these cases here to prevent it from rotating? You got to be careful to make sure the rust doesn't get into the surface of the crystal, which is going to, you know, have refraction with the image and not look right. You want to make sure that there's no leftover rust, because it will rust more if you don't get it all out the first time. And so these are the kinds of things that we're seeing. But, you know, pretty severe fluid intrusion here. And again, you know, by the severity of this, it was either used once, the damage occurred, and it sat for a very long time. But it's more probable that the damage occurred and then it was used over and over and over again, because the duration of time for this rust to occur isn't days.
Yeah, this is a long period of time. In fact, you know, you can even see it starting to build up on our connections down here. I was surprised if this would have even been usable after this, but, you know, even our flex circuits just have
so that's where we kind of talk with our customers, and you have to really start questioning the electronics to where, is it too fragile where it's not going to last anymore? And so we have those very very technical conversations and allow our customers to make the best decision for their facility.
So here we're seeing, you know, those beads I was talking about a moment ago, where we have scuff marks coming across them as it maybe was being pulled away from the patient, and that's just kind of your reflex. You bite down on anything that you don't like. But this is your seal between that harder, you know, intact tube that we have and the soft bending rubber. And if it's not sealing, if it's starting to compromise, if it's cracking, if it's weakening over time, you're going to start having fluid intrusion get in through there, which isn't really, you know, visible to the naked eye except for this evidence
and this is a really good telltale sign of how the probe's living its life, depending on the process or the people caring for it. Because, you know, down here the insertion tube, this is smooth, so if something drags across it, it's just going to be pretty much skating across ice. This stands proud, so it's kind of acting like a speed bump. It's going to hit this right here coming up and down from the teeth. And then here, this is smooth rubber again here, so where if it hits that and comes down, it's just going to drag and leave no evidence of, you know, of these teeth kind of dragging across it. So this is just a great, you know, a way to assess, you know, how probes are being, you know, inserted and removed from a patient, and if there's bite guards being used, to, you know, you can see this one has been, you know, pretty rough, and, you know, it's a pretty strong material for this to start gouging like that. Well, thank you so much for your expertise around this subject, and I'm sure we're going to continue to learn more with our customers, but, you know, we hope you learned a lot today, and, you know, we have a lot more, you know, videos like this coming. We have a whole YouTube channel if you haven't checked it out yet, and so, you know, if you like what you saw today, please subscribe to our YouTube channel. Like us on Facebook, follow us on LinkedIn, and, you know, we're going to open the floor for some Q&A.
Thank you, guys. That was good. We have had a few questions come in. I would like to start with what is considered maximum allowable leakage current for a T probe, especially when using different manufacturer test equipment?
We typically try to test using no more than 10% over ground. So using something like a barred leakage tester, it's going to give you a ground calculation and then a T calculation. And you want to calculate based on the difference. So what kind of leakage is actually escaping from the probe. Most of your testers in the hospitals are going to be simple pass-fails based on the same type of calculation. For instance, the Fluke TD800 is just going to be a green button and a switch.
Okie dokie. If you discover a hole before the probe is sterilized, how can you clean it thoroughly so it can be sent out?
In this situation, some imaging, at least speaking for ourselves, we're prepared to decontaminate or disinfect on site. So the process you would want to do at the hospital still is do a high-level disinfection using your soap and water with keeping care around that puncture mark. Or even better, if you can use the sterile sandy cloths, preferably purple top or gray top ones that are quite strong. And then make sure when you pack it into the box, it is dried out and that moisture is not traveling around.
Okay, another question that's come in is, what is a good approach to research if a T is properly repaired and tested?
Hi, this is Larry here. You know, a great way to validate is, you know, to, you know, research suppliers. And, you know, we're always, you know, talking about ISO 1345, how, you know, that really should be a requirement, you know, for any independent to, you know, service medical devices. But, you know, kind of going deeper than the ISO QMS is asking about testing protocols that are required within an organization, and then assessing those and comparing those from supplier to supplier. And obviously the supplier with the most thorough protocols will usually churn out better product.
Okay, another attendee has asked, she said, sorry if I missed it, but how often should T's be PM'd, and where would we find a specific procedure? I haven't had any luck with the manufacturer's website.
Kyle here again. In terms of TE probes, the timing is a little tricky, since these probes really should be tested after every use using a leakage tester and visually inspected. But going in, you know, a PM direction, I would say that is a situation where a biomed can go in and maybe do an image quality test and just verify the functionality of the probe. Would be preferred every quarter, using something similar to the ACR PM checklist, where you're checking for depth and clarity of image, and then performing a visual inspection beyond that, what maybe infection control would see. If you could even bring that down to a month, it would be ideal, but I know these hospitals are starting to get really, you know, pushed for time. And ultimately, you might see the transducer more often than that, just based on use, if your infection control team is catching the small bites and punctures quickly.
And so this is Larry here, and to answer that question in a little bit different context is, you know, when we're helping our customers, it's everybody involved to ensure that the performance and safety of that TE probe is good. And what we mean by that, it's not just you know, sterilization or infection control or the clinical engineer. These are the users, the surgeons, you know, the TE technicians that's actually using these transducers. You know, there's a responsibility on everyone to assess the performance and safety of the equipment at all times.
Yep.
And we believe it's unfair that it only falls on clinical engineering, when in fact the image quality issues and the performance of the probe, the specialists that actually use it are the ones that can catch it, during a scan. So, we go in and we try to, build really a team culture around the care of the equipment to make sure everybody has the right eyes on it, so the damage can be caught as quickly as possible.
Yes.
Okay, right, that's great, thanks. How do I trust if my T-probe is repairable, or if I'm just being pushed an exchange repair at an exchange price?
Ooh, that's a tough one. For Summit Imaging, we're just going to speak on the behalf of what we do with our healthcare facility customers. Is a very detailed report on the damage of the transducer with actual photos of the damage. We believe are critical to build a transparent and trusting relationship with our customers, to demonstrate and articulate what is failing on the transducer, and then assessing risk. And that risk that we're assessing is risk of repair yield. If this is a high risk or a low risk, depending on the damage and the ease of the repair, we really lean on those what we call discovery reports, and those come with all of our transducer repairs to communicate to the clinical engineers, but also gives a very detailed report on the damage involved, and that could be shared within a healthcare facility to the others that are, quote unquote stakeholders, like the users of the probe, sterilization, infection control, to identify where there could be improvements to prevent the damage in the future. So, these medical devices, they just don't break on their own. It's usually from accidental damage, and if we can identify where the accidents occur and see those patterns, then that's where we get our customers get the biggest benefit, is by instilling new processes or education to prevent that type of damage in the future.
Okay, that's great. And what's the warranty on T-probe repairs from Summit?
From Summit, specifically from us, our T-probe repairs carry a 6-month warranty as standard.
Okay, that's great. Okay, we've got time for one more question, and it's, how is the life expectancy of the T-probe, time and or utilization?
The life, like we kind of mentioned before, that's a really tough one to answer because it just depends on the care and the maintenance of the equipment throughout its life cycle. We have sites that never break T-probes, and it's maybe once a year. And we have other sites that send us, 8 T-probes in a month. So it's really about that education, and it's kind of like predicting a car accident. It's like, when is a car accident going to happen? There are no actuary tables to, assess the risk of this kind of equipment right now, because it's so driven by the users. And what we're finding is that, as sterilization departments are taking care of T-probes, we're seeing a big gap in education on what those sterilization departments should be doing or should be looking for in damage of the TEE probe. So, again, an extraordinarily difficult question to answer, but, to answer what is the life expectancy of it, it should be a very long time if it's meticulously cared for.
And regular care does involve often actually having the bending rubber and rings replaced, almost like a maintenance, but you're not going to find damage during those situations. You would have caught it and had it brought in before you had that chalk looking bending line or a distal tube like we were showing in the video.
Okay, that's great. Well, thanks, Larry and Carl, for a great webinar, and thank you again to today's sponsors, Summit Imaging. One lucky attendee will win an Amazon gift card for completing the post-webinar survey, which will appear on your screen shortly. If you're unable to see the survey, please email us at webinar@mdpublishing.com. For more information about our future webinars, please visit webinarwednesday.live. Thanks once again, everybody, and hope you have a great day.